Well, should we talk about this Higgs Boson discovery? Because I don't know what this thing is, and I've read a lot about it. And if you could track my eyes as I read an explanation of what the Higgs Boson discovery is, you would see that my eyes go across the page, and let's say the page ends here. Then my eyes just keep going in a lateral direction, and I just spin around and I look and see if there's a snack around. Maybe is it time for me to have a drink of whatever it is that I am interested in imbibing at any given point. But basically, this is it is part of, you know how they have the chemical, it's an elementary part of physics, I guess, that gives other aspects of other elementary parts of physics mass. So I'll go to what Tim Dowling at The Guardian has a helpful guide on how to explain Higgs boson to different people. And so I'm going to try it. For people you're trying to impress, I'll just go with this, is the Higgs boson is an elementary scalar particle first posited in 1962. I happen to know that it was posited by Higgs as a potential byproduct of the mechanism by which a hypothetical ubiquitous quantum field, the so-called Higgs field, gives mass to elementary particles. Well, I practically already said that without even having to read it. I don't know what that means. And this is what you would, how you would explain it to a child in the backseat of a car. And this is the one that I got. It's a particle that some scientists have been looking for because they knew without it the universe would be impossible. Because without it, the other particles in the universe wouldn't have mass. Because they would all continue to travel at the speed of light just like photons do. And now we'll go to Burger King. That's the way you would talk to that kid in the backseat of the car. But apparently, they've been collecting. They have built this massive, I guess, lab. I would call it. I mean, it's this massive structure in between France and Switzerland. It is a 17-mile circular tunnel. Thousands of torpedo-sized magnets, basically which bend beams of subatomic matter and create trillions of subatomic collisions. Costs $10 billion. It involves 6,000 researchers. And it's underground. They fire all these subatomic, I guess, particles and then collect terabyte after terabyte of data, which I guess they've only gone through like 2% of it, and prove what has already been laid out in mathematics, that there's something else there that creates mass for these kind of particles. Now, this is supposedly, and I've seen some reports of Mark Toma, who was at this conference at CERN, CERN, where a lot of these, I guess, physicists are gathering and are super excited about this. Although some are like, well, we still got to, really see that this is happening. But so far, it looks like it is. And apparently, in this standard model, right, and this is the model that it's like that chart that you have in chemistry, with all the different elements. Well, this is the same version of that, but for physics. They're building blocks. The standard model features two kinds of particles. There are fermions, particles of matter, which take up space. So obviously you can't have them occupy the same space at the same time. And then there are bosons, which are force particles, which can actually take up the same space. 4 forces include gravity, electromagnetism, strong nuclear force, and the weak nuclear force. The last one, the weak force, is the most messy and complicated of the forces, and the Higgs boson, or really the Higgs field from which it rises, is the reason why. For other forces, gravity, electromagnetism, strong nuclear force, the force carrying the particles all have precisely 0 mass. But I guess the Higgs boson gives the weak ones mass. Like I say, I don't know what any of this means. But apparently physicists are pretty excited about it. And some people are saying that when people look back at this time, they'll remember 2 things. 1, the Higgs boson discovery. And 2, the fact that we didn't do anything about climate change. All this other stuff, just commentary. Why wasn't the Higgs boson discovered in America, but instead had to be discovered somewhere beneath the ground in France and Switzerland border, I guess, around that area? Well, in Texas, back in the 1980s, American physicists were developing a particle accelerator, which is another one of these huge, tunnels, I guess, or I don't know, big pipes. And it was supposed to be 3 times as powerful as the Hadron Collider, which is where this discovery was made. But Congress cut off the funds. This is Steven Weinberg, a physicist and Nobel laureate involved in the planning. In the 1980s, plans for superconducting supercollider, or SSC, which would accelerate protons to 20 TeV, which I don't even know what that means, 3 times the maximum energy that will be available at the CERN Large Hadron Collider. They designed it for 10 years. A site was selected in Texas. They bought the land. They began construction on the tunnel. And in 1992, House of Representatives canceled the funding for the SSC. It was then restored by a House Senate Conference Committee, but the next year the same thing happened again. And this time the House would not go along with the recommendations of the Conference Committee. After an expenditure of almost $2 billion and thousands of man-years, the SSC was dead. And now it's been discovered in Europe, and will have all sorts of implications. And just the pursuit of that science has all sorts of implications to science in this country. And, of course, science is all just bunk anyways. We all know that the Earth is only 6,000 years. And it's just God does everything.